Hi folks, so what we're actually faced with here today is a problem on the ellipse and the parabola, and the question is based from the 2013 Junior Cert Higher Level paper question 6. So anytime you're starting off with these questions, especially the ellipse one, what you want to do is you want to read the information and see what things you learnt in class and how you're going to apply them to complete the question. So first of all, we'll just start off by reading the question. It says, the figure shows a design for a toy rocket. It says the curve BCDEG, so we can see BCDE to G, is a semi-ellipse. So basically that curve there going around there is a semi-ellipse, so it's a half ellipse, so it doesn't continue on over here. This isn't part of the ellipse, this bit is though. Okay. The curve LMN, so LMN, which is down here, is an identical portion of the same ellipse. So what we're going to have to do obviously is complete this ellipse first before we can obviously get this little bit here. The curve BA is a parabola with the vertex at B. So this bit here, BA, is a parabola with the vertex at B. The curve GA is an identical parabola with the vertex at G. So basically, parabola here, they're the exact same image of each other, just copied over. Okay. The lines CJ and EK, so these are tangents to the ellipse. Okay, from C and E respectively, so they're tangent points to points of contact. And what we have to do then is draw the given design showing clearly all constructions. So, starting off the question, sometimes it can be a bit daunting looking at this and you're kind of wondering where to start, but I would always start straight away. Question 6, when I say it in class, it's an ellipse question, so I start off looking for how I would complete the ellipse first, and the part of the ellipse here is B, C, D, E and G. I want to get that started, so then I can work off my tangents maybe later on, then I'm maybe onto the parabolas and maybe this bit down here on the same portion of the ellipse. Okay, so what we're actually going to do is we'll start off with that. So B, C, D, E and G. So first of all, when I'm working with the ellipse, I want to work out the major and the minor axes. So first of all, looking for measurements here, I can see the measurement from the middle up to D. I can actually see that measurement there is 85. Okay, so that's actually probably going to work out as my radius for my major axis. I'll just put in MA there for major axis. Okay, that's going to be my radius for the major axis because they did say it was only a semi-ellipse. Okay, the full major axis would work out to be 170, but obviously we only need this half of it. So that's what I'm actually going to start off with. I'm going to do a line. My major axis line is going to be at an angle of 60 degrees, and I'm going to measure up, starting down here maybe at the A point, I'm going to measure up 85 to get the middle of my major axis, and then continue it on and get point D as well. Okay, so I'll get A, I'll get the center, and I'll get D. And basically I'll start then by drawing in my major axis. To actually complete it after that then, once I get the semi-ellipse kind of started, what I actually always need then is the minor axis. Unfortunately here, it doesn't actually tell us the distance from the center to B, which would be the direction of my minor axis in this case. It doesn't tell us that length, so we're going to have to do a little bit of kind of working out here. And if you watched one of my previous videos, what we can actually see is we've been given the major axis, and looking up here, point C and point E, they are points on the curve. So we're given the major axis and a point on the curve, and we're going to have to work out how to actually get, using the point on the curve, how to get the minor axis. Okay, so we'll start on that there now. So what I've actually set up here is the 60 degree line running up through the middle. It's 170 long. Starting at the bottom here is point A. So I'll just put that in dark there. That's point A. At the very, very top, I've got point D. And in the middle, that is the starting, that's the point there, right there for my major axis. Okay. So starting off, I need to get the direction of my minor axis. The minor axis is going to be perpendicular to the major axis. So if the major axis is at 60, the minor axis 60 plus 30 is going to make 90. So just pop in the minor axis there. Don't know exactly how long it is, but I'm just going to roughly put in a line there, construction line. Just for purposes of my red lines here, these are all my construction lines. I'll be going over the heavy points with a marker later on. So starting off there, I am going to put in a major auxiliary circle, because I do have the major axis. So I'll just pop that a little bit longer there. So major auxiliary circle. From the center to D is my radius, because that's 85. Okay, that's part of our major auxiliary circle. now the next portion of the question is we want to work out how far C is away, or wherever C is, it's a point on the curve. So from the middle, which we have, it is up 44 as we can see here, and then it's going to be out 36 parallel to the minor axis. So up 44, out 36. So we'll find C there. So up 44, and then from there it's going to be out 36 millimeters. Let's just put that in there. And 36 millimeters right there is my point C. And if I wanted to find E in the opposite side, checked it out, and I could once again measure 36 millimeters. Okay, so there's my E. Now, what I have here is the major axis, and I have the direction of the major axis. I know the minor axis is going up here, I just don't know the exact end point of it, and I also have a point on the curve. Now, we have done this actually in a previous question, and it was explained in a previous video. So anytime you're trying to find the minor axis, what you're going to do is, and you have a point on the curve, you're going to go parallel to the direction of the minor axis to cut the major axis. So with C there, what I could do is, I'll project up, parallel because I know the direction of the minor axis, and where it cuts the major axis, here, I'm going to project it down to my middle. Now, what I'm going to do is to find the actual radius of the minor axis, I'm going to go bring C back parallel with the major. And what I find here is that little triangle, like we plot our points when we're doing the concentric circles method, that point right there, from there to there, is the radius of my minor axis. So I can put that in now, that being the radius. I'll pop in my minor auxiliary circle, from there to there. And now I have located points B and B, C, D, E, and G. Okay? So there's point B, C, D, E, and obviously G is down here. So with that now, what we can actually do is we can split it up into our various cut sections. So I'll split it up into my 30-60 degrees. Project that up there to locate our points. Find another point up here. Find the point out here. And straight across my page. So that'll split it up into roughly 6 sections there. Now just to locate the points. So B was a point, C is a point here. So what I'm going to do is where it hits the minor circle, I'm going to go parallel to the major axis. And where it hits the major circle, I'm going to go parallel to the minor axis. And the exact same at the opposite side. Where it hits the major circle, parallel to the minor. Where it hits the minor, parallel to the major, and so on. And we can actually see these points are actually working out here as well. Perfect. Okay. So now I've got my points there. What I'm actually going to do is just quickly put in my sketch. So I'm just going to speed up the video for the sketch part there. Right, just on the next part of the question here, what I'm actually going to start off with is I'm going to leave this bit here, and I'm actually going to try and fill in this kind of area inside here. I'll do in the circles in a while after. But what I'm actually going to start with is I'm going to start filling in the parabola from B to A there. And then the mirror image of that parabola will be from G to A as well. But I'll start with the B to A parabola. Now, the method for a parabola is we always want to create a rectangle. Okay, and this in this case we actually only have half a parabola. If it was continued on, it would go up here like that. But when we're creating that rectangle, the rectangle would look something like this. So it would. And that rectangle there is what we want to create, that box, okay? That is going to be 85 long and whatever height or whatever our radius length was for our minor axis. So, starting with that parabola, and what we're going to do is we're going to split it up, and I'm going to do I'll do it into 4 sections so we can get a roughly accurate parabola. Okay, so what I'm going to do is from A, I'm going to project out parallel, and that's going to be at 30 degrees, and then from B, bring this point down. Now B is our vertex, okay? So what we want to do is we want to split this line up, 85, just thinking 5 into 85, you go 17. Yeah, I'll actually do it into 5 parts. So 5 into 85 goes 17 millimeters, okay? So I'm going to split this up into 5 17s. Just happens to work out quite nicely that way. So 5 and 85, so 17. 17 is there. 17 plus 17 is going to be 34. Plus 17 is going to be 51. Plus 17, 51, 61, 68. 17 left over then. Okay. Now, parallel to our vertex, because they told us that B is our vertex, at all of these points we are going to project them down. Okay. And I know I'm going to need them over here because I'll do axial symmetry in a while to get the parabola on the opposite side. Okay, so my parabola on the opposite side is going to come like this. Now, if we've split up this side, we also have to split up this side. And because we've done 5 sections here, we're actually going to do 5 sections here. So the line here, I don't know what length it is, so I'm going to split it up into 5. And I'm going to do division of lines to complete that. So I'm just going to random line off. And I'm going to do measurements of 10 millimeters there. So 5 tens. So 10, 20, 30, 40, 50. At the last point, connect it up to A. And then just a little bit of sliding set squares to divide the line up completely. So that'll be that one. That one. There we go. We have now this line split up into 5 equal sections as well. Okay. So what I'll actually do here is I'll just use a little bit of numbers. So where B is there, I'm going to go 1, 2, 3, 4, and then obviously this will go back to 5. And then this one here at this point, so that'll be 5. Then I'll go 1, 2, 3, 4, and 5. Okay, so what we do here then is, at the points on the outside, because B is our vertex, we're going to join all of these to B because B is our vertex. So where 1 joins to B, cuts through there, that's a point on our parabola. I'll mark that there. And just for the purpose of keeping the drawing neat and tidy, I'll join 2 to B. I'll just put that one in as well. Where 2 is cutting through the 2 line, which is right here. That's another point in my parabola. And just as I said, for the purpose of keeping the drawing neat and tidy, all I'm going to do now is the 3 one is going to cut there, the 4 one is going to cut there, and obviously 5 is a point on the curve as well. Okay, so there's our parabola on this side. And if I wanted to locate the points at the opposite side, I could just do a simple bit of axial symmetry. So I could put my compass in there. If I wanted to find this point exactly, just around the opposite side, so I'll have to extend that line out a little bit. Same with this one. There's that point on the opposite side. The exact same here. And then the same with the last one. And there's our points. Just extend that out there a little bit further to locate the point exactly. Okay, and now at this point we've got all our points for the parabola, got all our points on this side for the parabola, so I'll plot my curve. So I'll just speed up the video there once again. Right, just going to do a little bit of tidying up inside in here now. So as you can see, we've got 2 circles here. They both have a radius of 18. So it's just a case of finding the center points for those 2 circles. We already have one here. It's just a case of putting in the radius 18. And we have another one down here. And that's actually radius 18. But if we remember from our original center of our major and minor axis, which was here, If the radius is 18, that means from there down to there, that length is 18 to find the centre for that circle. So I'm just going to pop the two of those in there now, so I'll speed up the video. Right, so the next portion of the question involves getting the tangents, okay? So we're going to get the tangents from C to J, okay, and E to K. And same thing with the tangents, they are going to be the exact same as each other. They're literally, once you find one, you can actually just flip it over and you can get the other one as well, okay? So I'm actually going to focus on this one up here, C to J. Now the first thing is, the J is actually, we don't know what length it is out from the middle of the line out to here. We don't know, but what we do know is we do know it's on that line there. So from the center down here of this circle, I'm going to extend my line out left and right, okay? And that angle is obviously at 30 degrees that we previously worked out. So I'll set that up first. So from the center of my circle down here, I'm going to extend my line out left and right. And somewhere along that is going to be J up here and K down here. Okay? And now at this point, what we have to do is we have to get a parabola touching the point C as our point of contact, okay? And anytime we get a parabola, what we need is our two focal points. And the method for getting the focal points when we have the major axis and minor axis is you take half the major axis, you go to the top or bottom of your minor to cut the major axis then. Okay, so that's what we're going to do. So half the major axis, go to the bottom of your minor or the top, and you can cut it here. That will give me one focal point, and there's the other one. And when you find the focal points, very important to label them. So this is F1, this one is F2. Okay. The next stage in construction of getting a parabola involves joining the focal points to the point of contact which was given to us, which is point C. So what I'm going to do is join F1, connect it to C, and extend it beyond C. And then the exact same with F2. Connect it to C, but extend it beyond C. And what we have there is two lines. A line from F1 to C and connected beyond, F2 to C and connected beyond. And what we actually have with those two lines is four angles. We've got an angle here, an angle here, an angle here, and an angle here. Understanding which angle to bisect will give you a parabola. And we can actually bisect two angles. If you wanted a line going in this direction, that wouldn't be the parabola, that would actually be a normal, okay? But if you want a line going in this direction, that will give us our parabola. So the angle we actually have to bisect is this one, or this one, okay? So we'll just bisect those angles there nice and quickly now. So from C, little mark there, and just about cut it. There we go. And what I'm going to do there now is construct my tangent. So from C, connect it to that, but just extend it out to this point here. And at that point there, we have now found our J. And it's just a case of heavying it in. There's our J. That will connect back to here. And to find that on the opposite side, just heavy in that there, to find that where K is on the opposite side, I could once again just do a little bit of axial symmetry. Rather than going through the whole process of bisecting the angles and stuff again, take the distance from the middle to J, could extend it out to here. That would be the exact same on the opposite side, and there's our K. And once again, just heavying it in, K will join to E in this case. There's our parabola on that side. We can start to see the rocket taking shape here. So in that little bit there. Okay, so that is the construction for getting the parabola. Anytime you get a parabola, you're always going, or not a parabola, sorry, a tangent. That is the construction for getting a tangent. Anytime you get a tangent, you're always going to need the focal points, which is half the major, which is this distance here, from the top or bottom of the minor will give you the focal points. Connect your focal points to through the point on the curve where we want the tangent, which was there through C, and then bisect the correct angle. Okay, so you can see now it's actually starting to take full shape there. And the next portion of the question that we have to complete is based down here. Okay, so first of all, what we actually are going to do is I'm going to input this kind of curve in here first before I get the next portion of my ellipse. So doing that curve there, we can see from A it has a radius of 47. So that's the first thing I will do. From A I'm going to measure up 47. 47 is working out right there at the edge of my circle. So I'm going to swing an arc. This is a construction arc. Move that out the way. That's going to be part of the base of my rocket. Zoom out there so you can see it a little bit better. That's going to be part of the base of my rocket here. Okay, so now obviously what we have to do, the next part and the last part of this question is, it says the curve LMN, because we did this portion of the ellipse, we have the parabola, we have the identical parabola, we have the tangents, and the last bit we have to do is the curve LMN is a portion or an identical portion of the same ellipse that we got up here. So looking at this LMN, what information are we given? We are given the width of the portion of it, which says it is 72 millimeters long. Okay, so working out there, 72 millimeters long, half of 72 from the middle, that means from this side here, from there to there is going to be 36, and from here to here is also going to be 36. So is there anywhere that we see 36 in the question? Now if you didn't realize that, it's okay, but if you look up here, that means the portion of the ellipse that we have to transfer down, the distance from here to C was 36. So that means the portion of the ellipse that we actually have to copy, the identical portion, is that part of the curve there. Okay, so that's what we're actually going to take. And 36 is a nice kind of round number. And what we're actually going to do, 36, if you think of half of it here, 36 divides up 3 times. We're going to take a series of cuts, okay? So 36 divided by 3 is actually going to be 12. So from C, we'll measure in 12 and then 12. And what we're going to do is we're going to take a series of cuts, a cut there and a cut there, and we're going to measure those distances. So the height from there to there. And what we're going to do is, when we have our line down here, our little box created, we'll have a box created down here in a minute, we'll measure 12, 12, and that height there will correspond with that height. The height for the next portion, from there to there, will correspond with this one, to plot the points. Okay, so that's the next part of the question that we're going to start on there. Right, so in starting that, what I would actually do is from here to here, that was my 36. So from A, I can actually bring back C. I could just transfer C back. It's at 60 degrees. I could transfer C back all the way down here from C. You can see that that was where I was matching up with. From C, bring that all the way down. And we can see where that's where it cuts my circle down here. I could do the exact same with E. And chances are, at this point here, and that point there, they're going to match up. And they do. Okay, they join up here. And that is where we're going to start our parabola, because the measurement from there to there is now 72. Same as here to here, C to E was 72 as well, because from C to the middle was 36. So I'll just connect A down as well, so I have the middle. Okay, and that will be the first kind of section. So what I'm going to do is I'm going to divide this up into 12, as I said. So from C in 12, and 12 and 12 is 24. I'll do the same this side, 12, and another 12 is 24. And what I'm going to do is I'm going to do those cuts, okay? And for the cuts, I'll actually just put them in green here for a second, just so we can see them. So these are going to go in green. Now this cut should be the exact same, depending on how well I drew my ellipse, but that cut there should be the exact same length as that cut. And then I have another cut here. Okay, so exact same thing down here. I'm going to measure my 12s. So 12, sorry, put that in red. 12. 12 is 24. There we go. 12. 12 is 24. So, transfer up my measurements there. They're going to be going up somewhere up there. Okay, now what I want to do is I want to transfer those heights. Okay, so I'll just zoom in there a little bit so we can see it a little bit better. So if I was to label it, actually, just to make sure, so I'll label it, just thinking, I'll go with numbers again. So C into the middle, so we'll just go 1 there, 2 there, there was 3, there was 4, this was 5, and 5 goes down to E. So C technically will be here. Well, in this case it's actually L, sorry, but L is the same as C, and then we also have N. So we found those 2 points, and now what we want to find is our D. So we'll get that one for 3, which is going to be in here. So that distance there, I'm going to take that height and measure it again, sorry, 1, 2, 3, 4, and 5. So all I'm going to do is take the height for the tree, which was from there to there, and mark it off in here. So that's my point there. And 2 and 4 should be the same, depending on how well, as I said, I drew the ellipse. So that distance there should be the same as this distance here, and it's working out the same. So I'll do the same with 2 and 4. So from 2, make a mark, from 4, make a mark, and it'll be the same then with 1 and 5. So I take that distance on the compass, should be the same as over here, and then I'll mark it off on 1, then I'll mark it off on 5. And there we go, we have our points plotted for our identical portion of the ellipse. So I'm just going to quickly sketch that in there now, so I'll speed up the video there once again. Right folks, there we go, that's the question completed there. Lot in that kind of question, as you can see, just to kind of get the overall structure of it. There was a bit of work up here in the ellipse. Obviously we had the parabola section here, and then down here we obviously had an identical portion of the ellipse, and on top of that we had to get a tangent as well. So quite a lot of work to do there to generate that image, so we did. Just going back over some of the important points. You really do need to know your constructions of how to actually get the minor axis when you're just given the ellipse and the major axis, half the major axis in this case, and a point on the curve. You're going to have to know how to construct your tangents by getting the focal points, and then for this bit down here you're going to have to be able to construct a similar portion of the ellipse that we got up here by doing a series of cuts. Okay. Once again guys, I hope you found that helpful. A lot of little tricky bits in that question there, just as I was explaining. On the actual exam day, you have roughly about 35 to 40 minutes to try and get that kind of question done. Now in this video it's probably taken me about a half an hour, but that's with me explaining. What I would always advise, just to recap, is when you get the question, plan out your question, how you're going to complete it, and as I said, always try and start with the ellipse, because that's going to be the main bulk of your question and how you're going to be able to construct that, and everything else will hopefully come after that, provided you understand how to get all these other little portions, knowing how to draw a parabola, and knowing how to get a tangent and so on. Okay, hope you found that helpful guys. That's the question done.